Right, okay, so today I'm going to look at the Laplace transforms, question 1 type of answers. Okay, so here I've got the table of Laplace transforms that you were given in the exam. So we've got, and what I'm going to call, as I'll refer to these in the answers, this is row 1, row 2, row 3, etc., row 4, row 5, row 6, row 7, row 8, row 9. Okay, you will be given these, and anything else that you need to learn, I'll highlight in the solutions. Right, so here are the questions. Right, the questions are: convert the following functions of time defined for t time greater than or equals to 0 to functions of s using Laplace transforms. Now the first one is f of t is 2e to the minus 3t. Okay, so if you were given these, first of all you'd look in the table for something that was e to the minus kt. Look, because if that extra, because we've got an extra 2 in there, well, that's going to be k times that, and that just goes in there. So our one here, which I've copied across here, row 4, look, it's row 4 is what we can use for this one here. Okay, and what you'll actually find is for each of the questions, I've already identified the rows that you need for each of the answers. Okay, so I won't keep flicking backwards and forwards to the table. Okay, so for this first one, you need row 4, and the function of time, if you've got 2e to the minus 3t, so we've got f of t, I'll just do this in red so it stands out a bit. We've got f of t is 2e to the minus 3t. So if we compare it to what's in the table, what's in the table is that a is 3. And then we can also have that k, a multiple in front, which in this case is this 2. So our k is 2, and that goes up there. K is 2. So you actually have the Laplace transform is 2 over s plus 3. And that's your answer there for that first one. Okay, B. Okay, so for this one, it's e to the minus 5t sine 2t. Okay, and I've already said it's like row 9 on the table. So I've looked down, what you look down at the table, it's this one here, that's one that we're going to use. And I've copied that answer across, so I don't have to flick around backwards and forwards. So row 9, if you've got e to the minus a t, that should say, sine omega t, f of s, is omega s plus a squared plus omega squared. So for this particular question, f of t is e to the minus 5t sine 2t. Compare across, a is 5 and omega is 2. So the Laplace transform, omega on the top, s plus 5 squared on the bottom, and omega is 2 squared on the bottom. So if you remember, we've got 2 divided, that went a bit wonky, 2 divided by, that's going to expand. When you expand the bottom, you'll have s squared plus 10s. And the constant, we're going to have 5 squared there, which is 25, plus 2 squared, which is 29. Okay, and that's your answer there. Okay, so part C, we've got, let's find this here. Part C, it's 3e to the t, which is one of these, with k3 and a minus 1. Then it's plus 7e to the minus 4t, which is also one of those. And then plus t squared, where you need row 5 for t squared. And row 5 here, look, t to a power n is n factorial over s to the power n plus 1. So that's what we need there, and I've copied that across there. So the red one, I'll do each one separately. So row 4 for the first one is 3e to the t. It's row 4 with k is 3, a is minus 1. The next one, 7e to the minus 4t. That's also row 4 with k is 7 and a is plus 4. And then the t squared is row 5 with n is 2. So put all this together and we get, we'll start up here. It's a row 4, it's this one, then I'll do that one, and then I'll do that one. So it's 3 over s minus 1. And then the next one is row 4 with k7, so it's plus 7 over s plus 4. And then the last one is 2 factorial over s to the 2 plus 1. Could have done all this in one step. 3 over s plus 1 plus 7 over s plus 4. Sorry, s minus 1, s plus 4. Then it's plus 2 over s cubed. I'll just put that there to a nice little bubble there so you can see the answer there. That's the answer for C. Okay, and then over to D. D, f of t, if you look at D, D is f of t is 4t e to the minus 3t, and E, f of t is 0 if t is less than 2, and it's e to the minus 3t if t is greater than or equals to 2. So I've copied these over here. There's D and there's E. Now D is not a straight, there isn't this combination on the table of t with e to the minus 3t. Similarly for E, it doesn't quite look like this on the table. So we need some extra rules for these two. So we'll go back to D. Right, there's something called the first shift theorem, which states that if you've got the Laplace transform of f of t is f of s, and that's notation you've seen already, then the Laplace transform of e to the minus at f of t is f of s plus a. So this will be in your notes somewhere. That will be in your notes. I've just put it here, and this is, you need to remember this. You need to learn this theorem. You need to learn this theorem. Okay, so if we look at this, we've got, so the e to the minus at is part of the theorem, okay, which is this bit here. So our f of t is this 4t. So we need the Laplace of 4t, and that is 4t to the power 1. So it's our row 5 again, because that's k times t to the n. So we're going to have k times t to the power 1. Okay, and then the a, the fact that it's e to the minus 3t, so a is 3 here, that goes in there. So it's going to be f of s plus 3 because of that 3 there. Okay, so what we can say, using the first shift theorem, as long as you can memorise that, you'll be fine. We have f of s is equals to, okay, so let's write up here, k is 4, that's there, that's 4, n is 1, and we've got to replace s on the, we need to replace the s here with s plus a, which is s, and our a is up here, so our a is 3. S has got to be replaced with s plus 3. So f of s is 4 times 1 factorial over s plus 3 to the 1 plus 1. And that is 4 on the top and s plus 3 squared on the bottom. Okay. And that's the answer there. And finally, part E, which I've copied across here. This one, f of t, is 0 if t is less than 2. And it's e to the minus 3t if t is greater than or equals to 2. The best way to do this is to go back to the basics of the mathematical definition of the Laplace transform, which is that f of s is the integral from 0 to infinity f of t e to the minus st dt. So what we get then, if we use this, ours is actually starting at 2. So we can say it's the integral from 2 to infinity. And it's f of t, which is e to the minus 3t. We don't have to worry about the 0 one, because it's just 0. So we start at minus 3t at 2. F of minus 3t, e to the minus st dt. So this is the integral from 2 to the infinity, e to the minus s plus 3 t dt. And then if we integrate, if you remember, e to the kt, the integral of e to the kt dt is e to the kt over k plus c, which we don't need to worry about today. So that we're going to apply that here, and the k is minus s plus 3. Okay, so this is going to be e to the minus s plus 3t divided by minus s plus 3 from 2 to infinity. Right, when you put infinity into the top here, because you can have a minus infinity, that's going to tend to 0. So you can say that is 0, and that's because e to the minus infinity tends to 0. And then the other one, it's going to be minus, and then we've got t, we've got to substitute t, look, the t, so t is 2 in there. So it's e to the minus s plus 3 times 2 divided by minus s plus 3. And then what we can say is these two minuses cancel out, because that's going to make that minus in that denominator make this whole term negative. So it's going to be minus minus, which makes plus. So we can say this is e to the minus 2 s plus 3 over s plus 3. And that's the answer for that one.